Hello, geometry students. Today we're going to learn about secants with angles this time. So if two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the measures of the intercepted arcs. So here we have an example of chords that intersect inside of a circle. Here we have an example of the secants that intersect inside of the circle. So we're focusing on angles this time. So we have a formula that we can use here. And if I'm talking about finding the measure of angle 1 right here, I'm going to focus on the arc of DC, and I'm going to add that to the measure of arc AB right here. But if it's angle 2 that I want to find, then I would, like right here, then I would focus on the measure of arc AD here and the measure of arc BC here. So as you can see, they go together, right? So if we're talking about these angles here on the inside here, then we're talking about the arc above and the arc below. If I'm talking about the two measures of angles here, we want the arc on the side and the arc on the side. So it's the adjacent, right? Okay, so let's give an example here. So we want to find the measure of angle AED. So AED, so we're going to go from A to E to D. So this is the angle that we're looking for right here. And if I use my example with my formula, it's pretty close to what measure of angle 1 would be. So this is the formula that I will use. So the measure of angle 1, we can call this 1, is going to be equal to 1/2. Arc DC was the one that was right here that belonged to it, so we'll say that too. So arc BC. So I'm going to say parentheses 109 plus, and now it's the other arc across, so I'm going to add that to 45 degrees. And all we have to do is use our order of operations to find the measure of angle 1. So 1/2. 109 plus 45 will give us 154. And we need to find half of 154, which I believe is 52, but let's go ahead and do this on our calculator to make sure. We always want to make sure, just in case we're going too fast. So 154, we'll divide that by 2, and that's going to give us 77. And right there is a good example why you want to do that on a calculator. So there you go, the measure of angle 1, 77 degrees. Well, the measure of angle AED equals 77 degrees. Okay, so a couple more examples here. We have example number 2. We want to find the measure of LK, our arc LK. So here we're going to find this. We are going to use the angle measures and our arc right here. So again, our formula we know is the measure of angle 1 equals 1/2 in front. The measure of arc, and I have LK here. I guess I didn't have to do that little parentheses, plus the measure of arc J to M here. I didn't have to do that. That's okay. All right, so let's go ahead and plug in the information that we have. The measure of angle 1 would be right here, so that would be our 62 degrees. 1/2 the measure of LK, which is X, plus the measure of arc JM, which is 74. And here we're going to have to distribute to solve. So we're going to put 62, distribute 1/2 into our parentheses, giving us 1/2 X. 1/2 of 74, which I believe is, let's see, divided by 2 is going to give us 37 right there. All right, and now we need to solve for X, so we're going to subtract 37 from each side of our equation. That will leave us with 25 equals 1/2 x. Here we still need that x by itself. So what we're going to do is multiply each side by 2. That will allow us to have x here, 1x. And then 2 times 25 will give us 50 degrees for the measure of arc LK. All right, and our example number 3 here. It looks like we are looking for arc CDE. So that's our major arc. We know that because there's 3 letters that indicate the arc. So we want from C to D to E, again using the angle here and then the arc straight across. So we can set up our formula again. The measure of angle 1 equals 1/2. I'm going to put angle 1 here. 1/2 the measure of arc CDE plus the measure of arc FG. And we're going to go ahead and plug in that information. So I have 128 degrees equals 1/2 the measure of arc CDE. That's our x, right here. That's what we're trying to figure out. Plus the measure of arc FG, straight across. So that will be our measure right there. Okay, and again, we're going to distribute. So 128 degrees, we're going to distribute that 1/2. So 1/2 x plus 1/2 of 73. So I'm going to put 73 divided by 2. We're going to get 36.5. Okay, and here we're going to go ahead and subtract 36.5 from each side. That will leave us with, here we go, 128 minus 36.5, 91.5 equals 1/2 x. Again, we're going to multiply each side by 2 to get that x by itself. 91.5 multiplied by 2, 183. So our answer here for the measure of arc CDE, that major arc there, is going to be 183 degrees. All right, one last example here. Now, if you notice, my information is a little bit scattered this time. I need to find the degree of measure for n, which is right here. So let's go ahead and mark this angle. And we know from our formula that we're going to be using this angle and this arc. So I'm missing that piece of information, but they did give me 135 degrees, which is going to help us because we know from past lessons that this is a straight line, right? And we know a straight line equals 180 degrees. So if I just cover this up here and see this straight line, I can subtract 135 from the whole 180 degrees. And from here, we can find the angle of measure that we need in order to solve for n. So from here, now I don't need 135 anymore. It doesn't disappear, I just don't need it. So I'm going to go back to my formula. So the measure of angle 1, which of course is here, I'll put a little bit 1 indicating that, it has to equal 1/2 the measure of arc ML plus the measure of arc JN. And no, it doesn't matter which one comes first because this, of course, is going to be our associative property and it doesn't matter. You can put this before that, but you're just adding. All right, so let's go ahead and plug in our information. From the measure of angle 1, we'll have 45 equals 1/2. The measure of ML will be 37 plus the measure of JN, which is n. From here, we're going to distribute like our other example. So 45 equals 1/2 of 37. Let's take a 37 and divide that by 2. That would be 18.5 plus 1/2 times n, 1/2 n. Here, we'll go ahead and solve our equation by subtracting 18.5 from each side. That cancels out for us. So 45 minus 18.5. That will give us 26.5 equals our 1/2 n. And just like our other examples that we have done, we're going to go ahead and multiply 26.5 times 2, giving us 53 degrees for n. So that is our last example for secants and chords that intersect inside of a circle.